Law of chemical equilibrium. This law helps us in giving the expression of the equilibrium, and it also gives us the expression for the equilibrium constant. The law of chemical equilibrium can be clearly understood by the example like A moles of A combines with if B moles of B, giving C moles of C and D moles of D. Suppose this is a reaction which is involving the equilibrium. To derive the expression for the law of chemical equilibrium, we take a help of another law called law of mass action. It is the law which helps us to find out the rate of a reaction. It is an initial rate method, and according to this law of mass action, the rate of a reaction is directly proportional to the product of molar concentration of the reactants raised to the power their stoichiometric coefficients. So, the rate of a reaction as per this law for this reaction will be proportional to the product of molar concentration of the reactants A and B raised to the power their stoichiometric coefficients, which are small a and small b. The proportionality is opened by a constant called K, and this expression becomes like this. We write small f in the subscript of this K if we are talking about the forward reaction, and therefore this rate of a reaction can also be called rate of forward reaction. So the rate of forward reaction as per this law of mass action is equal to Kf A to the power A and B to the power B, where A and B are the molar concentrations of the A taken initially. Since these concentrations are the initial concentrations of the reactants, that is why this law is called initial rate method of determining the rate of the reaction. This Kf is called a rate constant for forward reaction. This is called rate constant for forward reaction. Similarly, we can write the expression for the rate of backward reaction, because once we know that equilibrium is there existing in this reaction, the reaction will be moving in the forward direction, as well as the reactants will be reacting with each other and forming the product also. So, what we can write is this rate of backward reaction is equal to Kb C to the power C and D to the power D. The rate of backward reaction. Kb, the rate constant for backward reaction. What is C and D? The concentrations, molar concentrations of the reactants, because now in the backward reaction C and D are your reactants. So molar concentrations of C and D raised to the power their stoichiometric coefficients. Now let us write down the expression for the state of equilibrium for this reaction. The law of mass action is used in writing down the expression for the equilibrium for this reaction. And as per that particular law, we already know that the rate of forward reaction is equal to Kf a to the power a and b to the power b. Also, rate of backward reaction is equal to Kb c to the power c and d to the power d. So we know that as at equilibrium, rate of forward reaction is equal to rate of backward reaction. We can write these two expressions in place of these two. Kf a to the power a, b to the power b, kb c to the power c, d to the power d. Or it can be written as Kf over Kb. We can bring the Kb down here and we can take a and b with the coefficients down here. We can write down this Kf over Kb, which is actually is called K equilibrium. We write K, which is actually indicating the equilibrium constant with the subscript Eq. So this Keq is the called equilibrium constant because the ratio of the two constants, rate of the forward reaction constant and the rate constant for the backward reaction will also be a constant, can be expressed as a ratio of the product of molar concentration of C and D raised to the power their coefficients upon the product of molar concentration of the reactants A and B raised to the power their stoichiometric coefficients. This expression is actually is according to law of chemical equilibrium, which states that at the state of equilibrium, the ratio of the product of the molar concentration of the products raised to the power their stoichiometric coefficients to the product of molar concentration of the reactants raised to the power their stoichiometric coefficients is always constant, and this constant is called equilibrium constant. K equilibrium is your equilibrium constant, and this is what we always wanted. This is what we have done in the characteristics of equilibrium, that at the state of equilibrium, since measurable properties are constants, their ratios which will also come out to be a constant, which is called equilibrium constant.